All right, quick addendum to let's see, two videos back where I did the shape. One silly mistake I made is I defined the constant pi as a long instead of as a single or double. So we were getting just the value 3 instead of 3.14159, 3.14195. Okay. There's a song there somewhere. So just something we should have corrected had we caught it. Moving along, let's see. Let's do something a little bit more with that last example of the bounce of the arc, the projectile. Let's do something similar and then maybe put some bouncing or something in it. Um, so let's start from scratch here. Basically, we had a vector, a position, uh, and a force as vector objects. Let's see, we had a position, a force, and a vector. All right, position. The vector dot x, I'll make 0, and so we don't really need to define that. Dot y equals, was it -1 or 1? Let's see. Let's try -1. Let's make it -2. And then we'll make our position. I'll keep position at 0 for now. In fact, I'll just use translate to make that go to the center. Well, then in the drawing object, translate, and I'll put it in the center of the screen. I'm just going to guess that it says 400 by 480 by whatever. I don't know. Sorry, let's see. 640, 480 maybe. Maybe 800, that would be better. 800 because 600. Let's see. All right, good enough. That'll be where we start drawing. And I want a, let's see, I got my force. I want a vector. Sorry, that should have been force. We want a vector, which will be, I want to move a little bit in one direction and a little bit, yeah. Actually, I think this should be positive. All right, so let's do our little for loop thing here. That should be, I got to begin draw. This should be end draw. Let's do a for loop inside of there. Let's go to 500. All right, so let's do what we did before. We'll start with position dot add. Let's do this vector dot add force and position dot add vector. I think is what we did, right? Then we'll draw it, d dot ellipse position dot x comma position dot y comma 0 comma radius. Let's just do 10, and we got to refresh at the end of that. We end the draw. We begin the draw. Let's see. This doesn't need to be in the middle of here. Let's take our begin draw and move it here. We'll clear the screen. All right, so let's give that a shot. Give it an optional translate. Translate always has 3 parameters. Use equals. Not sure how I made that mistake. All right, there we go. That was being a little overly ambitious. Let's make this 400 and make this 400. All right, there's our projectile. Now let's define a place where we want this to bounce. And basically Newton's law, the angle of incidence equals the is equal. How's that go? Equal and opposite to the angle of reflection, something crazy like that. Basically, once it hits a certain spot, we're going to reverse this projectile by adding, by just basically reversing this. So now I don't rightly off the top of my head remember to do that, but let's just do that. Let's say if P dot y is greater than, we started at here, we started at 0, so let's make this 100, then if, and let's put some logic in here, then position, then vector equals, let's see, vector dot let's multiply this times the negative value times, actually we're supposed to multiply by a scalar. Scalar is a singular value. If we had multiplied it, it would be by another vector. But multiplying by a scalar lets us multiply by a single value. And in this case, actually I don't want a scalar though. I want to do multiply by another vector. In this case, actually in this case, instead of doing that, let's do just the y parameter equals v dot negative v dot y. That should be it. Let's see. There we go. We got a bouncing ball. Let's make one other change though. You see what we did there? We hit pixel value of 100. We started at 0. Remember we put this translate in there, so it's starting actually at 400, but internally it thinks it's at 0. We got down to pixel value, y value of 100. It says, wow, we've gotten past that, so let's reverse this. Let's make this y force, the force of this vector, negative. In other words, it bounces and it goes in the opposite direction. Now we're going to take this and multiply this by like 0.9 because, let's see, times 0.9. Because anytime you bounce off of something, you lose some energy, right? It's not perpetual motion. It's going to lose some energy each time, and eventually it'll come to a stop. Or at least it'll be bouncing in such a small amount that you won't really see it, or it'll look like it's just kind of barely jittering. So let's do this. And, whoops, let's see. Not sure what happened there. Huh, it's strange. It worked the first time, and then it got down here, and, oh, you know what's happening here is it's still below 100, so it's continually doing that instead of bouncing up like it should. It still thinks it's below, so we need to add a little cheat in here that moves it back to 100. So let's go to you know what I mean. Let's go to the position dot y equals 100. So now it won't be confused and thinking it's less than 100. This basically is constraining it from going below this value, or below our just like in real life, you can't go below the ground, right? Unless you're like, you got a shovel. All right, there we go. We've got a bouncing ball using very simple physics. Very simple physics. Let's see if we can animate that again. Let's take this refresh and put it on the inside of this draw loop, and let's also I think we need to clear. Yeah, let's try it that way. What else do we need to do? We need to move, actually we need to move both of those within the next loop. So let's see what happens here. All right, let's give that a shot. I messed something up. Okay, so Well, whatever it did. Actually, refresh needs to be after end draw. Okay.